electric field strength. If I divide both sides by the area, so I get I over A, I over A equals sigma E. And I over A is just my current density. And you get the Joe equation. Now, back over to, I guess, this one right here. Now, the electric field strength. We are making an assumption that the electric field throughout the wire is constant. And I know that if the electric field is constant throughout the wire, then I do have a relationship between electric field and electric potential. I know that it's the Ed equation. I know that my potential, the electric potential is, my change in potential, or potential difference, is equal to the electric field times the distance. Again, ignoring signs. So my electric field is just the potential difference divided by however long the wire is. And so this equation here can now become I is equal to sigma A delta V over L. We're nearing the conclusion of this. Questions up to here? All right, so conductivity is material specific. There's nothing to do with the geometry of a material. That's where A and L will come in. But for sigma, that's the conductivity. So the bigger it is, the easier it is for things to conduct through it. And you can also sort of flip it on its head to create another variable. So 1 over the conductivity. So as conductivity gets bigger, this value gets smaller. Or as conductivity gets smaller, this gets bigger. This is known as resistivity. Resistivity is used more than conductivity, at least my experience. So my equation, instead of sigma there, I can write I got A delta V over rho times L. Really close to it now. I'm going to rearrange it so we have delta V by itself. Delta V is going to be my current times rho L over A. Rho L over A has its own special name. This is dependent upon the material and then the geometry, how long the wire is and what the cross-sectional area is. This is known as resistance. Symbolized by a capital R. So, starting with Coulomb's law, working through the math and the definitions and a couple of assumptions, we end up with the following equation, that the potential difference across a resistor is equal to the current times the resistance. This is Ohm's law. Now, I don't know if George Ohm found this experimentally or he actually derived this equation, but he gets honored with it. Let's take a look at units. We know, so R therefore would be delta V divided by I. So the units of R would be
second over
Volts per second over Coulomb?
or like volts per amp.
I was thinking volts per amp. So it would be volts per ampere, which would be a volt per Coulomb per second, which is a volt second per Coulomb. Volt per amp, so if you were, this is what you were saying, then yeah, it's also that. Which means actually, well, let's get to one more thing first. That's too much for people to write. Volts per ampere, come on, what kind of machines do they think we are? Instead, they came up to honor ohm. It's the unit called an ohm. And again, using the incredible logic of ohm. What Greek letter kind of sounds like ohm? Ah, omega. So it's a capital omega. A horseshoe with a lot running out. Questions before we start doing some number stuff? Actually, before we do the number stuff, what are the units of resistivity?
Coulomb squared per kilogram.
Did you get that?
Back when we first were looking at conductivity. Oh, but yeah, when we were looking at conductivity, we had the E squared and over mass.
E squared in tau
Yes, over mass.
over mass. So that would be Coulomb squared. That's the number of charged carriers per unit volume, so that's per cubic meter. Tau would be in seconds, and all that divided by kilograms. So that would be a Coulomb squared second per kilogram meter cubed. Let's see if it actually works out. So therefore, the units of resistivity, doing it that way, is a kilogram meter cubed per Coulomb squared second. If I know that a kilogram meter, well, you tell me, what's a kilogram meter per second squared?
Newton.
All right. So if I pull the kilogram meter per second squared times meter squared over, let's see, if I did a meter squared second over Coulomb squared, that works out, right? Kilogram meters cubed over, okay. So then I have a Newton meter squared second over Coulomb squared. That gives me a Newton meter times meter second over coulombs times coulombs. What is a Newton meter? Joule per coulomb? Yeah, so I got a volt times meter second per coulomb. What's a coulomb per second? Unit.
Oh, man.
So this is a volt meter per ampere. Ooh. What's a volt per ampere?
No.
So the units of resistivity in ohm meter. Although what was originally said is correct too, just ohm meters, which are generally seen as.
How would that relate to ohm per meter amp?
So resistivity is, well, so if I have resistance is rho L over A. Wait, you threw something else in, sorry, what was that? I think I went off my tangent.
Oh, never mind. I messed up my algebra.
Okay.
I see.
So the units of so rho would be R A over L. So my units of rho would be ohm meter squared per meter, which is just an ohm meter. All right, that was fun. Let's see, can we squeeze a unit of time out of that? So if that's equal to, well, that's equal to an ohm meter, that cancels out with one of those. And so a second is also an ohm coulomb squared per Newton meter. Another unit of time. I did tell you about that test question years ago, right? My favorite test question? One of my favorite test questions. Which of the following are units of time? And it had all sorts of bizarre, funky combinations. Not taken into, there were 15 choices. I did not take into account how much time it took to do each one. But too many students missed the letter S as one of the units for time. I think they were just psyched out at that point. All right, so if I have a wire, or how long ago I want a 1 ohm resistor, I'm going to use number 8 gauge copper. Number 8 gauge is a reference to the thickness of it, and you can, there are tables out there where you can look it up. The number 8 gauge has a cross-sectional area, 8.37 square millimeters. That's the area of number 8. And I want to figure out how long it needs to be. How long the piece of wire do I need? Well, let's solve for L. L is equal to RA over rho. R is 1 ohm. My area, what is that in square meters?